In Chapter 4, we're going to be talking about the forces and moments that affect the aircraft. In particular, we're going to be looking at gravity, aerodynamics, and the propulsion of the aircraft. So in this video, we're going to define our control inputs, and then we're going to see how they affect the system in simulation. And then we'll actually look at our first force, which is gravity. Then in following lectures, we're going to look at the aerodynamic forces and moments. We'll then talk about stability derivatives, and this is how do the aerodynamic coefficients that we learn about affect naturally the motion of the system. And then we're going to talk about a propeller and thrust model, and we'll end Chapter 4 discussions with a wind model. So let's go ahead and get started. As we saw from the previous chapter, we went through and we were able to find equations of motion for the entire system. So we have, here's the 12 degree of freedom representation. We can also take out the our roll, pitch, and yaw. Whoops. We can replace our roll, pitch, and yaw with 4 quaternions. Not 4 quaternions, but 4 quaternion elements that make up a single quaternion. Okay, so we can have, from Chapter 3, we learned about 12 or 13 dynamic equations. The objective of this chapter is how can we, and we see here in the inputs to these dynamic equations were our forces in the x, y, and z direction, and those are in the body frame. And we also looked at our moments and saw how those moments affect our system. So Chapter 3, we were able to just look at the effects of the forces and moments on the aircraft. Well, in Chapter 4, now we're going to come up with equations for both our forces and our moments. All right, and we're going to develop these in the body frame, and we'll see that these are, most of these, or a good number of these, are naturally, a good number of our forces that are acting on the system are more naturally expressed in the body frame, and the moments, I should say. Okay, so there are 3 different effects that we're going to look at. We'll look at first the gravity, so we'll denote that F sub g. And this one's our easiest force to look at. We'll also look at the aerodynamics. We'll call that F sub A. And I should say that each one of these things also causes moments. So we'll have the aerodynamic moment. Gravity does not, because we're going to model it as at the center of mass. And then we'll have our propulsion. So we'll describe our propulsion as F sub P and respectively M sub P. So we'll talk about each one of these forces and moments separately. But these forces and moments will directly be affected by the control surfaces of our aircraft. So let's talk about that really quick. So we have a depiction of a nominal aircraft shown right here. And we have 3 different, well, it shows 4 control surfaces, but we group the ailerons into a single control surface. So we have our ailerons, which we denote by our delta sub A. So our ailerons will result in a positive roll rate. We'll have our elevator, which we denote as delta sub E. That positive elevator command will result in a negative pitch rate, and our delta R will be our rudder command, and a positive delta R will result in a negative yaw rate. And you can see, especially with the delta R and delta E, so our elevator and our rudder, you can see how that would affect the system. So if you're just considering the delta R, so these are aligned with the axes of the aircraft, and so a positive So the delta R is going to be aligned with our K is going to be parallel to our K sub B, K super B. So that's going out the belly of our aircraft. And so that's its axis of rotation. So a positive rotation would move that rudder over to the left. And so now as you see that rudder moving over to the left, it's going to be getting hit by the wind, and that's why it causes the negative yaw rate. Okay, and a similar thing, we have the axis of rotation for our elevator is, we're going to say that that's parallel with J super B, so it's coming out the right wing. And so when we do a positive rotation about that, that's why it's moving down. It'll get hit by the air, and that'll cause the vehicle to then pitch down. And then our aileron, we're going to do a linear combination of the left and the right, as we see here. And again, the axis is going to be along JB, so going out the right wing. Okay, so we have these control surfaces. Really quickly, to introduce Chapter 4, we're going to look at how these control surfaces affect the aircraft in the simulation. So we'll jump over to the simulation, and what we have here is we have our aircraft. In our control panel, we can start, and we can, I should put the mouse on the right screen. So there's our aircraft. And then we have our control panel where we can start and reset it, and we can throw in these commands. And these commands, we can go between -1 and 1 for our throttle. We didn't talk about, but that's gonna be our propeller forces. And then we have our rudder, aileron, and elevator that we can command. Now I have it set here at some nominal values, and we'll talk about those nominal values next time in Chapter 5 when we discuss trim trajectories. And a trim trajectory, it is mentioned throughout Chapter 4 readings. Trim trajectory is basically a trajectory that are the control commands that'll move you about a desired motion. So, for example, these ones are set so that when I start the sim, our aircraft will move nominally straight along a nice straight line path. Now, we do have errors in our dynamics when we're calculating this. Let's see if we speed this up. That eventually we'll see that our aircraft starts to, oops, wrong button, starts to shift off of that nominal straight line trajectory. And remember, each one of these squares is 100 meters, so it took it a while to actually shift off that, and now we're doing a nosedive, right? So the trim trajectory is really nice in that it allows us to define a trajectory which the aircraft left uncontrolled it performs fairly well for a little bit. So we'll pause that and we'll reset our motion. So now going back to our control surface commands, let's just take a look at if we perturb each one of these just a little bit. And one thing to notice that these are all non-zero. For example, it requires the elevator as negative, meaning it's trying to pitch up just a little bit, and that pitching up allows it to stay at a level flight for that small amount of time we saw. Right, and so to keep us at a straight flight, we require just a tiny bit of rudder. We require our ailerons. Remember, our ailerons are for the pitching, so we want to affect our pitch, and that reason is because we have our motor going that's going to be putting a moment about the IB axis that we want to overcome. So we have these non-zero values that'll keep us moving straight. But let's just go back one at a time. So we have our aileron is what we mentioned first, and we said that would a positive aileron will result in a positive roll rate. So let's just bump this up. We'll put that at 0.1 to really create a big effect. And again, the roll rate, A positive roll rate is going to have the aircraft, if we're looking at the IB axis, it's going to be rotating around that IB axis. So I'm going to put this sim speed back to 1, and then we'll go ahead and start it. Oh, I didn't put the sim speed back to 1. Sorry. Let's reset it, and we'll see what happens in a little bit slower. So now we see that we definitely are rotating about that. And the other thing, that is its main motion, that it's rolling about that, but we'll see later on in the lecture that there is a minor effect on a different moment. So it's not just going to affect the roll, but that is the major thing that it's going to be affecting. Okay. The next thing we mentioned was the elevators. So in this case, a negative elevator command will cause a negative pitch. So let's put this one back to 0. And this one, let's perturb it even more. And so we'll make it more negative, and we should see that we have a larger pitch. So I'm going to hit enter so that we actually get it. Okay, let's start our sim. So there you see we're going to pitch up, at least for a time being, and then it ends up causing some additional effects on the aircraft, right? But you saw that we definitely had a major impact on the pitch angle. So we'll pause that, reset it. And then the final one we talked about was the rudder. So let's put our pitch angle back, and we'll change our rudder. And in this case, we said that our positive rudder affects, it's going to give us a negative yaw rate. So let's go back and so if we have, in this case, we have a negative rudder, and that's going to result in a positive yaw. So should be turning basically to the right. And there we see definitely turns to the right, and we'll see later on that it's going to also affect the roll angle. Maybe we should make that a little bit less crazy on our rudder, because we saw the secondary effects pretty heavily. Okay, let's try that one more time. There you go. So now we start to see that we are yawing, and we definitely are rolling a little bit too. Okay, so we have these. We can get the primary effects from our control, and we can then see, and we can see that indeed does affect the aircraft. So now we're going to be jumping into all the remainder forces and moments. But before we do that, we'll come in here and we'll look at each of the we'll look at a few different configurations of the aircraft to show that these are pretty general configuration. So let's jump back into that. So here's our nominal aircraft. We can also have a different configurations for our aircraft. So in this case, this is what's called a V-tail. Well, you notice that the tail between this aircraft and this aircraft are slightly different, right? So in this aircraft, we have the axes aligned. We have a well-defined rudder, and we have a well-defined elevator. I should be pointing here. So we have a well-defined rudder and a well-defined elevator, right? In the V-tail, our rudder and our elevators are somewhat combined. So we have this slightly different tail configuration, but we can actually get the elevator and the rudder inputs as just a linear combination of the actual inputs to the aircraft. So we can just map these V-tail inputs just into our elevator and rudder commands, and we can then model the system as we were. So then we can jump into another configuration. We have our flying wing. So instead of having a tail at all, we now have what we call the elevons. And again, we can get the elevator and aileron as a linear combination of these elevons. Now, it feels like we're missing a couple of our inputs, but we'll see later on that those inputs, we can use the secondary effects of these inputs to help us get the desired effect from the ones we're missing. So really quite awesome. We have a few different configurations, and we can all map those back to this our conventional system where we have ailerons, elevators, and a rudder. Okay, so now we'll jump in and we'll talk about our very first force. And this is the force of gravity. And the one beautiful thing about the force of gravity is that it's really easy to define in the inertial frame, and if we define its effect on the center of gravity, then it won't cause any moment on our aircraft. So the gravity vector is expressed in the vehicle frame, and remember that the vehicle and our inertial frame are parallel, so this is just going to be effect in the z-axis, and we'll note that this is positive. This is just our mass, and this is our gravity constant. And normally 9.81, and you can keep it going. All right, so we have a positive in the z direction, and that's just because this is a positive down vector, right? So we have our vehicle frame is aligned with northeast down, and so that creates, so we can do a positive force for gravity. Okay, so to express that in the body frame, what we're going to do is we'll just take our vector, and this was just FGV, and we're going to rotate it from the vehicle to the body frame, right? So this is a transform from the vehicle to the body frame. And then we can get our vector in the body frame. And so if we're using Euler coordinates, we get this nice relationship right here where it's just going to be mg, and then we have these trig functions on our Euler angles. And if we're using a quaternion, a very similar thing where we're just going to get mg times the elements of our quaternion. So we now are able to take our very first force and map it into a force, a body force, right? So the important thing to note here is that our gravity may affect all of our axes, right? Our body axes, that's what I was trying to go for. Excellent. So we have our very first force. So there you have it. We'll start to just define these forces and define their effects. And in the next video, we'll jump into our second set of forces, and that's going to be dealing with our aerodynamics.